So I'm Erwan Galen from Red Hat, I'm the product manager for the product OpenShift, and today we will discuss of a great partnership we have with NVIDIA, with DPF. So I recognize in the assistance some people who have built this journey of telco with an evolution starting from 2G, 3G, 4G, so the journey of Red Hat for the telco platform has started with telco cloud platforms in the early days with OpenStack. And we have continued to develop on being the leader for the telco cloud. Introducing OpenShift for 4G and 5G, and also with complete evolution on the requirement of the platform, starting from the voice to internet, moving to a low latency network with 5G and with 3GPP, 5G Advanced. So for AI, we see a huge increase of requirements for every type of agentic AI or machine-to-machine, where the network and the platforms should evolve. So Red Hat is positioned as a leader for every footprint, starting from far edge, near edge, regional data center, and centralized data center. So you can install the same stack on all these footprints, running your RAN, AI, edge computing, mobile core. So with the same API, we can provide single plane to run and to provide consistent operation. So one of the difficulties of the vertical stack is really the complexity to aggregate multiple applications. So with a Red Hat OpenShift in a Red Hat Hybrid Cloud, so you can deploy faster and you can also innovate better. So with this partnership with NVIDIA, we are introducing today Bluefield on the Red Hat OpenShift to enhance the infrastructure performance for the network and to also provide feature on increased performance for AI. So with Bluefield, so we have started this journey with supporting Rails, supporting our system on Bluefield. So I don't know if all of you have already used the DPU. So the DPU is a system in a PCI form factor, so fully independent, running with this collaboration. We have used 16 ARM cores, 32 gig of RAM. And you can run services. It's a full system. So NVIDIA has developed this system, but one of the difficulties was the life cycle of the DPU and how the DPU can be integrated in the platform to provide flexible programmability on the function you want to deploy on the platform. So it's why we have collaborated together, and we have provided this integration between OpenShift and the Bluefield DPU. With this integration, we are also providing additional functions as service function chaining, that not only one function can be installed, a monolithic function on the DPU, but also multiple functions. It's also a key differentiator when you can not only enable one function, but multiple functions, having a marketplace, and using an API, you can easily integrate multiple functions. So it's not a detail, this integration with Kubernetes and OpenShift on this integration of multiple vendors. It's really putting all together that providing the value of the platform. So I will present the integration we have done with DPF, so Docker Platform Foundation, where we provide the lifecycle, the management, the provisioning for DPU, where we can deploy with OpenShift on the framework DPF, the Bluefield DPU, and we can instantiate and deploy specific specialized network function with the help of what Elad was mentioning, two network operators running on the host. So why it's a game changer? So with DPU, Bluefield 3 DPU, you can enable enterprise on telco. This technology is here for a long time in telco cloud, but it was requiring some specific teams, some specific development to maintain this technology, and it was quite a huge effort to maintain. With this integration, we automate everything. With the use of an operator, it's easy to deploy first, set up the configuration, but also after to manage lifecycle, the different functions you want to install on your platform. So in fact, it provides the streamline management on GitOps, DevOps that you can apply with OpenShift on the host. You can now also apply the management of your Docker services on the Bluefield. So it's a flexible integration, and it provides also a capacity of putting multiple vendors. So it's why you can run your AI application or telco application. You can also make evolution of your network. So we have seen the evolution of the network that we had more and more machine-to-machine, more and more requirements. You can also reconfigure your network in a classic AI platform. You have east-west traffic with dedicated connectics or super NIC. But for this north-south, you can provide a lot of flexibility and evolve quickly and have also visibility with monitoring. So with this integration, on this integration with DPF, we use Kubernetes on OpenShift to manage the Docker services on the DPU. So on the top, you have the cluster of the host called the management cluster with 3 controllers and 2 worker nodes. So x86 controllers, you find the 3 controllers, and each of the 2 worker nodes has 1 DPU, and each of the DPU is a worker node. So it's why we can orchestrate and we can run services on the Bluefield. So because it's a hosted cluster, you don't have controllers. So it's a Kubernetes management, and Red Hat also provides support of hosted cluster with Hypershift with a product hosted control planes. So how to deploy and how to install? Because when you have this running, it's really easy. You can just call your API, and with the work in the Docker, you can easily apply service function chaining. So with the design, we have on the management cluster on the top a control plane for your host. And we just simply install, after you set up the controller, and I will make a quick demo, we install the control plane, and the DPF operator will automate all the configuration and all the installation. It's what I was explaining on the simplicity of installation and solution. And this DPF operator will provision the hosted cluster on the Bluefield, provision the DPU with a BFB image, and run Docker services on the DPU. So we will not go in all the details, but globally, we remove Open vSwitch from the host. So we have OVS running on the DPU. And Docker management service is managing all the life cycle of the Bluefield, starting with the provisioning using the AirShim to provision the Bluefield, and after also all the integration. So here you have an example with 2 pods connected to OVS on the bottom on the Bluefield tree. And in this example, we are running host-based networking, so HBN, which is a router, has Docker services. But HBN here is an example. You can put multiple functions, and in our example, we put multiple services that we can chain together. So how we deploy the Bluefield? So it's everything Kubernetes concept. When an operator will install first the controller on the host, so we use for this assisted installer. And we create some DPU object in Kubernetes. On this, we deploy the Docker management services pod, configure the networking. After, we have an automatic reboot on the host. The Bluefield join the cluster in the hosted cluster. So I will make a quick demo. So here we have a small setup with 3 controllers running on a virtual machine, 2 worker nodes, x86. Everything is x86 for hypervisor, the worker node. On each of these worker nodes, we have a DPU Bluefield 3 with 2 interface, 200 gig, using NVIDIA Cumulus. And we will deploy DPF and we'll configure the Bluefield on this network. So here we start by deploying the 3 controllers. So it's a really simple assisted installer when we set up the 3 controllers. after, when the three controllers, we will add the two worker nodes, so the two x86 worker nodes. The only thing we have to do is to create a specific bridge, so same classic configuration. So the two worker nodes are registered, but to get the connectivity, we will start the setup. So we start by installing the DPF operator. So here we see the cluster, and we install the DPF operator. So after the DPF operator will manage everything. So it will create the hosted cluster running on the host for this use case. We can also, we plan also to have different location. We apply DPF manifest. At this time, we download the BFB image. The BFB image is ready to be deployed, and the DPU can be provisioned. So here on the top, so we see the DMS pod starting on the deployment of the blue field with a DMS pod provisioning. So the two last blocks in the terminal are, each of them are the blue field. So the deployment is automatic. So in a classic deployment, you have to push yourself the BFB image. Here, everything is automated, and you have a reboot where the configuration phase can start, and you see that the cluster, the hosted cluster, is ready. So after, we can check and connect on each of, with the airshim, we can connect on each of the blue field, and we can see that we have the connectics of blue field, and all the card has been prepared with a firmware update, ready to run and to receive the services. And we see the Bluefield version 2x 200 gig. So now to manage how we will deploy Docker services on this function. So we will use, we see here the cluster ready to run the application. And we can see how to configure. And in this context, we will deploy a Blueman and HBN using DPU set to configure. With a simple file, when we describe the list of functions on specific configuration, just we can configure the service function chaining between those. And after having deployed this, we have HBN available, and here Blueman with telemetry information. And the good thing is you can really put multiple functions. You can put a Blueman on any other type of function or an F5 function, and you can run it. And I finish with benchmarking on two nodes when we use a benchmark between with IBPerf. So we do one RDMA test, and we'll do a TCP test. So here we have a full service function chaining with HBN on Blueman. So we run the first test with RDMA, and in this test we can see that we will reach, so it's an aggregated bandwidth because we have two interfaces to 200 gigs, so we reach 383 gigs, so like 96% bandwidth performance. On the second test, we are running an IPerf test with TCP. On here, so we reach 360. So it's an average between 90 and 96% on this test. Okay, so in this test, yeah, we have seen that we can really reach line rate with, quite a full chain with BGP between the HBN service, NVIDIA Spectrum switch, and really showing the performance also of running Docker services on the Bluefield that can leverage also all the accelerated features available on the Bluefield. So this service function chaining is providing value on operational automation with Kubernetes and dynamic provisioning, and it can be automatically configured also for any troubleshooting because you have just a description file and you can automatically configure. So as summary for this demo, so we have shown how OpenShift and DPF can deliver Bluefield lifecycle, full management with the installation and configuration. So we have seen how we can use service function chaining, providing management and flexible service integration when you can pick Docker services. We have also some customers interested in running their own function. They can collaborate also with NVIDIA to create this function and with us. And this platform can also provide isolation for some specific use case. When you want also to isolate some function on your blue field, you can isolate the management, the routing on your blue field. So thank you to the team. So we have done this collaboration with team in Israel. So Sagi, Igal, and Ram, who were contributors with all the NVIDIA engineering team. So we are really happy of this partnership and that really providing value for AI networks and telco networks. Thank you.
Thank you, Erwan, and thank you, Elad. First, I'm really pleased with the partnership with NVIDIA. It's been a really great journey. I'll try to share with you what we have been doing so far, but also the partnership with Red Hat. For some who do not know, we are running one of the largest, together, one of the largest 5G mobile network in the world. And without disclosing too much, the Super Bowl has been supporting all that traffic without any glitch, unlike probably some of the centers in California where you cannot have coverage. Today I'm going to talk to you about this collaboration, but for the ones who do not necessarily know what we're doing in F5, in simple words, F5 has been the leader and still the leader in application and application delivery and security for about 25 years. And we are serving the top 20 banks, the top 20 telcos for both IT and 5G, and their mobile core, actually 4G and 5G, probably 3G, 4G, and 5G, as well as the top 20 agency in the world. And if we're doing that, or leading that, for good reason. The technology we have built over the years enabled them to run their application, their business, in the best possible way. Few reasons for that. The technology, you can simplify it as a proxy, but it's not proxy. It is very solid, extremely high performance. Whatever capacity you have, you can run it line rate, layer 4, layer 7. Fully rich in terms of capabilities. We support tons of protocols. And it is fully programmable. If you need something that you don't have, you can program it. You have a high-level language called iRules. It allows you to do what you want. So in a nutshell, this is what BIG-IP does. It's not only just load balancing. It's not just a traffic management. It is additional security, firewall, WAF, so layer 3, layer 4 firewall, but also layer 7 WAF, web application firewall, URL filtering, DDoS, but also DNS. All of these capabilities are done in one pass. One pass, you have all the services at the same time. And for the last few years, we have been embarking on a journey to modernize this technology that we've been running for the last 25 years and make it cloud native. Cloud native means that runs natively and efficiently on a Kubernetes cluster and support all the microservices and the complexity of running such an environment. It's not doing only ingress services and egress services like what we discussed this morning, but adding all the capabilities, especially in a complex environment such as Kubernetes. Because we have great partnership with Red Hat, and when we deploy OpenShift, you need additional functions to operationalize your clusters, to run your services, to observe your service, to make sure that you monitor them, and you have something like 5G running, you understand what's going on when you have a glitch. These networks cannot support any downtime. So that's the journey we have been on. And recently, we announced the support of this technology on the Bluefield 3 DPU. We announced it last October. We took our technology that is running on, especially for the Kubernetes, the ingress and the egress controller, the most important capability, especially for such environment, and we embedded on the Bluefield. And the results are stunning. For the ones who missed it this morning's session, SoftBank has tested with Red Hat environment, and the results are stunning in terms of performance achievement, latency, 11x better than what you use, if you use an open source or use the CPU, and the power saving, it's outstanding. The numbers is 190x better when you compare the watt per gigabit. 190, and it has been tested in Japan. That means it has been at least verified 10 times, not 190 times, but at least 10 times. So these are the outstanding numbers, the value you get from offloading such layer 4, layer 7 capability on this DPU. It gives you an idea of the power of the DPU when it comes to the offload, as well as the saving you can get from the ARM core supported on this card. That's the basic. Then you have additional capability. Security, this is what we do. We do the full security, as I mentioned, from layer 4 firewall, the full NG firewall, as well all the way up to layer 7. So for tenant isolation, tenant security, different policies, you have everything you need. It's fully flexible. You have the load balancing. This is how we grew up. We have very flexible, fine-grained load balancing. And when you have complex environment and you need to distribute your traffic on the right GPU at the right time, real time, we can do that. So make sure that your cluster is up and you don't have a GPU that is overloaded. That brings everything down. That's what we do. Third, or fourth point, we learned a lot from some of the development. I said this is operationally mature, this is a new product. We just adapted to ARM. We learned what we need from observability perspective. So when you have multiple applications from multiple sources running in the same environment and one of them is misbehaving, because that's going to happen, you will have the right information. You can observe what's happening in your network and you can solve it in the fastest way. Because if you don't have the right information, if you don't have the right observability, you're going to spend time. Meanwhile, your multi-billion, multi-million cluster is down, is not at work. Your capital is sitting. So we enable that. And probably, it's not cherry on top of the cake, but something extremely important for inferencing, and I think all this conference is about inferencing. We enable true multi-tenancy. We equip Kubernetes with a true multi-tenancy all the way to layer 7, because Kubernetes by definition doesn't have that concept. We do it at the data path level. You have multiple ways how to do it at the control layer, at the management layer, but we enable that at the data path level, and we do the tenant isolation and the tenant security. So 3 things usually resonate. The multi-tenancy, we thought that that's the cherry on top of the cake, but that's probably the most important thing for inferencing, especially when you start running agents and you have to attach your agents to various applications. You have an agent for ServiceNow, an agent for Slack, an agent for SAP. You're not going to mix them in the same namespace. You need to separate them and you need to isolate them, even though they belong to the same organization. So that's something that's becoming more and more important, and you lead to tenant isolation and you need to observability. So this is one of the use cases we start emerging, and this week we have multiple conversations about such requirement, and it's extremely resonating, and I'm glad to see many of our customers would like to have testing and start POC, because this technology is ready. Also, multi-tenancy enables you better usage of your infrastructure. If you're not sharing your infrastructure, you're going to have one block, one big cluster for one application. If you are sharing it, you can oversubscribe your infrastructure, and you can have better benefit, better ROI from your investment. And of course, you can isolate them. That's what we can do on the DPU. That's the interesting part of the technology integration. Now, this is what we have been doing so far, but because our technology supports additional modules, we are enabling, as we speak now, the additional modules to run on the same DPU, starting by the firewall that is deployed today as NG firewall, as GI firewall, sorry, in multiple telco environments, powering one of the largest, many of the largest telcos in the world, the 5G in the world, whether it's 4G and 5G, sorry, whether it's virtual or cloud native. We support DNS, we support DDoS, we support URL filtering. So all the capabilities you see them below now are enabled also on the DPU. Then you ask the question, what are going to enable to me? So here I'd like to thank NTT Docomo, that pushed us to show the value And one of the first values very much linked to the deployment of the edge AI, where you can select the traffic on the DPU. Sorry, step back. Entity Docomo built their own UPF, and they embedded this UPF on the DPU. They saw the value, putting that DPF in the DPU. I think they announced it last time at GTC. Now, like any UPF, it requires additional capability from security, from everything required for the N6 interface. It used to be the GI LAN for the 4G. This is what we can do. But in this specific case, we are enabling that infrastructure to select the traffic between the UPF and the AI infrastructure and leverage the entire GPU availability to do both UPF when you have the traffic, AI inferencing when you don't. This is what we're doing for the first use case. The second use case is same thing. Instead of having just UPF and go outside the DPU and find something for the GI LAN, the N6 security, we're embedding the same thing on the same DPU. These are the two use cases enabled and tested by Entity Docomo. Now, when you start putting all of this together, you go back to what everyone was talking about. Now you have multiple software components, not all of them coming from the same vendor. You have multiple drivers, you have multiple provisioning, and things become complex. This is where the DPF comes to play, making sure the lifecycle management, the day one operation, a lot simpler than when we used to have, especially in the the NFV environment, and even the early days of the Kubernetes environment. Something that made life of telco operation very difficult and got in the way of scaling some of the deployments. Now we're solving it with DPF. When it comes to day zero, from provisioning all the way to day one, and day two from operation, to simplify what we have. Without forgetting the security. The security is important. Tenant isolation, tenant security, Erwan talked about it. Same thing, we can enable that. Now, to summarize this for you, three things, very simple. The installation, that takes time. Erwan did the demo. I wish we could have done it all together, but it was a little bit last minute. The installation, that's simple too. You have a button, you click, and almost you have the installation in a few minutes. Provisioning, getting the right image, the right drivers, the right information you need. That same thing, part of the DPF. And last not least, the configuration. Configuration is something that is live. You need to have up to date. You need to change, and this environment is not going to be static. Same thing, we can do that. So this is the value we're getting from the DPF and both the integration of the Bluefield DPU, but working also with Red Hat OpenShift. In short, in summary, this partnership, three-party partnership, is enabling us to do three things. One is the AI factory for some of the telcos. Many discussions this week. It's not straightforward, but there's so much value. We saw this morning with SoftBank how much saving you can get from such implementation. My favorite part is the saving in terms of latency that could be translated to more token that could be translated to more dollars. As they said, they will have to quantify that numbers, but at least we have the first signs of the gain. Security, of course, and inferencing when it comes to, especially multi-tenancy when it comes to inferencing. We're not forgetting the distributed 5G, the distributed UPF. If you are running distributed UPF in a constrained environment, you need to have more space, less power, but more capacity. That's what we can do, and we can jam all together, and we can orchestrate. With DPF, we can orchestrate all of it in the smoothest way. Last not least, the edge security services, as we discussed. 3 use cases we can enable right away with a partnership with NVIDIA and Red Hat. Thank you very much.
Okay, thank you. I think we have a few minutes for questions. So let's open it up. I want to thank you for a wonderful presentation, gentlemen. Okay, do we have any questions? I know it's getting late. You guys are anxious to get over to the exhibition hall, but here we go.
By combining these functionalities in the DPU, are you seeing any kind of power savings? I mean, if not this case, then you need to provision a separate server and you need to run all these things. So what kind of power savings you are able to see, especially the far-edge scenarios where you have power limitation is high. So just wanted to understand that part.
The power saving for the DPU. So we have very good data points. We had this morning, and I encourage you probably to watch 8 a.m. session with, of course, NVIDIA and SoftBank. The saving, if you normalize it to gigabit per watt, compared to an open source, 190x saving in terms of gigabit per watt. So literally giving comparing 300 meg per watt against 57 gigabit per watt. Correct me, Benito, if my numbers are correct. Yeah. So that's the amount of saving you have. 190x, and I said the test happened in Japan. They verified it 10 times. It's not insignificant.
What version of OCP will this operator be available on?
So for now, this demo has been done on the latest for 17, on the still integration, on preparing the next release. So still integration phase.
There's a question there. Okay.
Question.
Thank you, Lior from NVIDIA. I'm curious. Can you take this technology and apply it to enterprise in general? Let's say a bank that wants to run Red Hat OpenShift cluster with security, load balancing, etc. Can we take it, and when can we take it to customers?
This technology is not discriminating. It works for telco, it works for banks, it works for government. It works in any environment where we have Red Hat OpenShift. You have a 5 big IP next for Kubernetes. And you have security multi-tenancies to solve, as well as energy to save. But telcos are probably the first hungry and the ones who get it. That's why we're starting with them. But as I said, it's not discriminating. You can send it to wherever you want.
Ready to go. Okay, got a question here? Yeah.
Hey, thank you. Yeah, Amitai from NVIDIA. I want to get your perspective on how this collaboration between the companies applies to things like sovereign AI that is emerging in the telco market.
It's a very good question. You want to start, Erwan?
So yeah, we have really a lot of sovereign for Red Hat sovereign cloud requests. All of the country also want to build their own capacity for AI with GPU. And one of the issues of, if you look, as I said, an hyperscaler using this type of technology for multi-tenancy, for low latency, it requires a lot of effort. And it's why we provide this technology also to sovereign AI. Red Hat has this experience with the telco. We have a lot of regulation, and same for sovereign cloud, we have this regulation. And with all the work we have done during 10 years on FIPS, on all this regulation, this type of platform are available, are helping for the future, but also can reach a sovereign cloud, sovereign AI. So it's providing quickly a level of an hyperscaler to a sovereign cloud. So it's why this technology is useful, and Red Hat also providing all the compliance for this.
Yeah, data sovereignty requires, not data sovereignty. Sovereignty requires at least a couple of things: data locality and data security. We encrypt, decrypt at very high speed. We make sure there's data security. And once you have this private AI deployed in country, I think we can enable and allow lots of capabilities. I think alone we cannot do it, but with a partnership with the likes of Red Hat and NVIDIA, we can enable that.